Yeah, hello. As you heard, my name is Bachner, so I'm the operations director from the release liner plants. Great to be here today to really share our stories related to our digital project, what we did or we are still doing our release liner plants in Hilm in Austria. As you heard, we have 3 different presenters. This is my team in the background. I want to give you a short overview about the agenda. So first of all, I want to share our story with our experience of the PI system itself. Then a short introduction about the project itself, and then we are going really dive to the details, technical-wise, and at the end, I'm back again. I will do the summary and the conclusion. Who we are. So Mondi Group, so we have 4 different business units. So we are included in the consumer packaging, in the business segment release liner. So basically, what is a release liner? A release liner is basically a paper, so we are buying paper, and mostly we are putting silicone on that. Why we are doing that? So it's important for a customer that their applications will not stick to our base paper for that their products are really working in the correct way. So you can see it here. So graphic arts, car wrapping is one of our industry groups, tapes, labels as well. It's a big market. Industrial, hygiene, and envelopes. So envelopes business is quite important as well because everybody is buying stuff with Amazon. That's good for us because there is always an envelopes on it. So please do that. It's great for us. It's a good market. What are the advantages what we have in our plant network? Here you can see our plant topology, let's say. So we have a great advantage in all our sites because we started 2007 with the implementation of the MES system, and thanks God that we took the right decision to decide for OSIsoft, including the MES system from Siemens. And we rolled it out in a few years, and we have in all the plants a similar structure. So that means everything what we are doing in all the plants, like best practice sharing, extension of functionalities is great because it's done very easy, and we have the opportunity to do that quite fast, and it's great for best practice sharing, as mentioned before. The project what we are talking about now is the plant in release liner Austria, next to Amstetten in Lower Austria West, and therefore we started a pilot for analytic project. It's quite important for Mondi because we have a lot of pilots triggered. I think there are as well a few Mondi colleagues here. They are aware about that. This is one of the pilot, and great to show the content for today. And we are at the final stage, and we are proud to share our story. PI system. As I said before, 2007 we started with MES rollout, and we bought also PI in that package. So what we did the last year was really we added functionalities, we improved our processes, we increased transparency in the production, and thought this is really a great opportunity for all the plants to be better in all the areas which are around or in operations. So the traditional project approach was really great because before we do not have PI, we had to steer our operations, let's say, with the stomach, old-fashioned. From up that point, it was really great to see what's going on at a glance. And we had really fact-based data, which was great to start the normal project approach, and we tried as well to improve, or we improved already all our main KPIs. What was the benefit of PI the last years? You can see it here. So it's quite easy to explain. So the OE was increased with our main KPI, meters per attended. We did it on the slitting department as well. We started a lot of improvement projects which were related to run speed, and which was really very important was the reducing of plant waste, because we have a lot of different kind of wastes in the whole plants where we were not aware what's going on, and with the PI we had a great transparency to start here great improvement projects. With the normal project approach, it was fine. So we had our benefits, it was great, but we asked ourselves, what is next? With PI, we collected since 2007 a lot of data, and we asked for ourselves, what we are doing now with that data? Yeah, it's great to have the data, but is there a benefit to use that data as well? and we created a workshop, and we decided, okay, we want to learn from our data, because we have a lot of different projects running on our lines, and we have a lot of different process parameters as well, where we have to care about. And we know exactly that we had a lot of projects running in the past with sometimes different settings, because the raw material is a natural product, let's say. And as always, the machine itself has a lot of different possibilities for setup and possibilities to change something from the operators. We said we want to learn from our data, and we want to have a system which tells us which would be the best setting for exactly that product at that moment when we run that order. Sounds easy, but we have thousands of process parameters, and we started really the project with that approach. And I can say it was a great outcome till now, and my colleagues will show you more in detail, and I will do the conclusion afterwards.
My name is Johannes. I'm leading the digitalization project in the release liner plant in Austria. I want to bring some more light into the announced project. First starting with a coating line, going into some more detail. This is a typical coating line, what that you find in a release liner plant. This is machine number 5, where you have typical setup of unwinding location for paper, running the paper through the machine, through a coating head, applying the silicone Jürgen was talking about. The material moves through a drying section before it gets cooled down, moisturized, and then rewound, in short. And that is the line where we had our most accurate data, a lot of process parameters collected over several years, and we decided to put our pilot project to this machine. Right, so Jürgen already mentioned that with our traditional approach, we had improvements, and we wanted to find out if there is value behind first the data that we have, and if we could generate value through applying advanced analytics. So the first idea was, we could use machine learning, you could use proactive monitoring, looking at quality systems, and then we came up with the idea to develop a product that recommends to the operator how to set up the machine while it is running. Second, we concentrated on quality indicators. One of the main ones that we look at is the release value. And clearly, after analyzing, we wanted to make sure that these operating windows get displayed to the operator, that they in the end know how to set up the machine. And well, as you saw on the plant network, we had 6 plants with the same infrastructure. And if we succeed on that machine, there is a potential to scale it and roll it out to the other plants. So what was the expected source of value? Reduce the application of silicone, reduce rework to run the material twice through the machine, reduction of customer claims as we focus on quality parameter, and improve process stability. There is another one that we didn't mention on the slide. Currently, there's a lot of experienced operators where we live from the experience the operators have. If we build a system that has, well, knowledge in the end, or good algorithms in the background, we get less dependent on experience, so there's less risk of fluctuation in plants, so there is some more value that we have behind. What is different to the traditional approach? This one here is new way of working, means continuous process control instead of the project approaches that we took in the past. For operators, it would also be very different. Instead of, well, gut feeling experience, they would need to look at a system that we develop, a display or notifications that they will get, and stick to, well, the new parameter proposals in order to produce stable product quality. So that was the first ideas, and we knew, well, not all the knowledge we have in-house, so we tried to find out with which setup we could succeed in such a project, having had a lot of meetings on last year's PI World, and we found OSIsoft, which we had in the plants, is one of the partners, finding out which tools to use, which how many text to use, which, how you say, interfaces we would need, or what products we would need. Then we had PA Solutions, which is an integrator, making sure that we get the correct setup of templates in AF, getting calculations in, connecting external databases where we don't have the data maybe in-house at that time. Plus pmOne, where Georg Droschl is going to present, the advanced analytics company, which supported us during the complete project. Just to let you know, we started in December last year. And no, that's too fast. Yeah, and how did we structure the project? At first, when we started, we didn't really know if we are going to succeed, as it is a pilot. So we decided to say, okay, first step, we ensure to have the database. So what kind of data is relevant for our process? Which of the data do we have on site? Which additional data might be interesting or might influence our process that we need to consider? That were the main questions behind. Then, after this is clarified, we decided, okay, milestone taken, move to point number 2, model identification. Let's see if we are able to find an algorithm that works in order to predict our quality parameter. And number 3, well, if we succeed, which until now we did, how could we visualize the outcomes through PI Vision in an easy way to make sure that the operators really take the right decisions, that they really stick to the recommendations. Before we started, in order to build the data lake, we had a workshop about the data household. Well, the questions I already talked about. And here at the bottom, you see the data stream that we have identified and established for model building. Means here is SAP as an ERP system, Siemens is our MES system, plus linked the PI system, that's what we already had. Then the AF structure, we defined from scratch after this workshop in the data household, set it up, put a template that would work for all the coding lines. This allows us to export data from the PI system, which also contains some data from the MES system, like products or customer names, orders, etc., and export the data through the PI integrator into our data lake, which is right now in a SQL database. And from here it moves to an Azure environment. Plus, as we did not have all the data in this stream through the PI system and the integrator, we needed to upload some data manually into the data lake. And we decided to do it manually in order to say, okay, we have our big data lake. From that we start the model building. If we need that data, we could still integrate it in the normal data stream. From here, data analytics started. There will be some more sentences about it in the next slides, plus the outcome to be visualized in PI Vision, plus if there is action to be taken, notify the users or operators or process engineers in our case. So the current data stream that we worked on works now without the manual data load, and we made sure that we use our infrastructure, meaning MES system, getting ERP information into the PI system, like quality data, for example, and move this to the data lake. Which in this setup would allow us also to operate the system, retrain it, and quickly deploy it again in the live environment. Oh yeah, now I hand over to Georg.
Thank you, Johannes. Good afternoon. My name is Georg Droschl, and I am with pmOne, and I'm responsible for the analytical models in this project. So let's now dive deeper into the data flow that we've just seen, especially on the machine learning box. So we had 2 goals for data science and analytics. 1 is to predict quality parameters, and 2 is to make recommendations on how to set up the machine. And one of the first things we did is we looked into the data. There is a couple of years of data available, and did a simple exercise. As you can see on this chart, we plotted them onto a simple chart by the date that the tag was first available. Okay, and if you see at the bottom part, there's a lot of boxes over there. This is when the machinery was being rebuilt. And what you want to do, what you want to have, is a consistent set of data. So this bottom area, which is the first half of 2016, we couldn't be using. So we could start only after that. On the other end, there were some new extensions to the plant. It's always growing. And what do you do with a tag which doesn't exist for most of the time? You can't use it anyway. So this is why we started with about 500 tags for the machinery itself, then grew to 900, which is also for the environment, looking at about 2.5 years of data. The first model we took on was one model which is being used directly in production. It's the COBB, it's the coverage of the silicon. And the benefit is one that it's available right after production, and also because it has just a few values to it. And in this team, we were very close collaboration with the experts on the plant, and we used another visual technique, in fact plotting each of the tags against the outcome. So when you look at this colorful diagram over there, it turns out that for some values of COBB you have higher values than you have than lower values. And for building this model, you have to make a decision. Which tags are going to be used in the model building? And basically there are two approaches. You can throw everything in, which adds a lot of possibilities, but also a lot of complexity. But on the other hand, you could start from scratch, keep adding one by one, which is easier to manage, but wouldn't give you the full breadth. And in this project, we'd like to share with you that it was a combination of the two. So the domain experts from the plant, they would provide the tags, the know-how they had, and the data scientists add further tags relevant. We then moved on to the key quality KPI, which is release. And depending on the kind of product, if you have a diaper, if you have a tape or some car wrapping, the stickiness has to be different, and this is what we want to control. Second, the release value is only available 24 hours or later after the lot is being produced. And as you can imagine, there's a lot of things which can happen in 24 hours. So what we want to do is, in fact, make a prediction right when the lot is being produced. It turned out we had two models. We have two models for release. One is the specific value, so it's a kind of a regression type of model. Little more complex than that, but it's the continuous value. And the second one we added only afterwards is kind of a traffic light. It's a classifier showing the operator how well he's doing. Now that you've seen three prediction models, that's kind of the eyes and the ears for the operator, so giving them new capabilities. But also, we wanted to get one step further, making a specific recommendation on how to set up the machine, and this is where the parameter recommender comes in. So all of those four models go into one chart, one flexible display, which is being displayed directly in PI system. It's the operator display developed by our project partner, PA Solution. Let's take a look at the IT environment which is required. If you look at the bottom part, that's what you've already seen from Johannes. It's the existing data flow and the existing set of components. And when you look, you have now more than 3 years of data, you have about 900 tags, and you sample them every second. It's more than a terabyte of data. What does it take to do training and to do analysis so that maybe you go for a coffee, but you don't have to wait overnight to get your model built? So this is why we added a development environment, and taking into account that we had periods where there was a lot of computation, a lot of workload on, and other times where there was not so much, the cloud is just perfect for that. And we chose to add the Microsoft Azure environment as a development for the models. And we're using Python for all the analysis, for the programming, Databricks for the computation, and in combination with Spark. So finally, before handing back to Johannes, let's take a look at some numbers. For each model we have been developing, we had these cycles, development on historical data, and then validation on live machine data. And this is where it really got interesting. And what you can see here is for the release value, for the historical data as well as for the live data, that we keep adding new products, and we actually can predict for about 90% of the roles the correct outcome. And what's next is, of course, working on accuracy and extending it to more and more product to cover more and more of the production. Thank you.
Okay, so we would be here. So Georg was just talking about the different models that got developed. And after they got developed, we brought them back into our own local PI world. And after this deployment, it was very important to make sure that with the real data, well, not training data, but real data coming from the production process, we validated the data. So in order to make sure that there was a group of people that, well, how you say, collaborated with us in order to validate the models, we made sure from the start to have a local project team that included the subject matter experts, included the operations people, so they worked with us from the start. But we still have a good commitment here, and we also get very good feedback on the different models that got deployed. So typical validation period was 4 weeks per model, and then there was a second cycle, and again 4 weeks. And the products that were part of the models were in a, how you say, check sheet, and whenever the product was run, notes were taken, the notes came back, we had a joint discussion about it, and included, well, ideas, findings into new features of the models in order to improve them further. And by doing so, right now, the knowledge of the complete project, the models, the predictions, is also already part of the organization. Well, the result, we have confirmed models and buy-in, because all these models are nice computer games somehow, but you need to get it deployed in production in order to get your value. And that's the next challenge here. So the 4 models that you see on that slide, and Georg talked about it, we were thinking, how could we combine the findings from all the models and make it fit to our production process? You saw the machine running typically with two operators. These guys are pretty busy during production. They don't really have time to stand in front of a computer and watch a screen. So we were trying to, well, develop ideas how we could implement it. And the outcome is the display here in the big picture, where it's maybe not the most fancy display that you can build in ProcessBook or PyVision, but it has the main elements. So here, this section is the recommendation piece, showing the 10 most important parameters for producing one specific product on that machine, right? But as we don't want the people to stand in front of the screens and wait till a prediction or a proposal is showing up, we were thinking, okay, how do we make sure they only take action when action is required? How do they get informed that there might be action required? And that's how this traffic light system at the left side came in. So in the first traffic light, it's the classifier that Georg was talking about. So this classifier tells you there is a product that might be of bad quality. Behind that, there is a notification, and the process engineer currently gets informed that he needs to have a look at the product. The second view he could do is, it's the COP prediction model. If this is on green, he knows that the coverage of silicone is already okay. So one of the topics is already ticked off. And then he can still decide over here to adapt the machine settings to the proposed values, which are here in the green boxes, right? And at the top there is again lights which would say this one here was modified and the light is now after the recommendation green again. Yeah? Before it was not, it was set on 20 and the target was 10, was changed, it's green. So this is also how you get feedback directly. Yeah, and right now we are learning in the production process, well, if the predictions of the model are good, if we really should change settings, and we are still keeping track of all the changes. Jürgen's part.
Okay, yeah, that's the summary. So what we have to do now, so we have to refine the model, find operating procedures that the operators are really sticking to the recommendation. So I think it will work well because we had them really included from the beginning. That's quite important, as mentioned from Johannes. For sure, when everything is done, we want to roll out that pilot to the other plants as well. So it's a great benefit related quality because we are really saving time, money, rework. So, and this is a good example how analytics, it's my opinion, how analytics can really help in daily business, in daily operations. And it's a great project which we can really be proud of that. And thanks again to the team, especially to my team, Johannes, to the team of pmOne, Mr. Droschl, and as well with PI Solutions, and for sure OSIsoft, which was the basement for all our digital project, what we started, especially for that. And we are open for other projects as well. So this is, we have now a data lake created, as you know. So this is one project which is related to quality, and we have a lot of other opportunities. And so we are really, ambitious to do other projects as well. So the overview. We had our challenges for sure, as you heard. So we found a solution. It's great. So now it's up to earn the benefits, let's say. So the goal is to really save 8% of the rework. So it's a lot of time and money, as I mentioned. And we have to refine the model and put that to the other plants as well. And then everything is working fine and as expected. Great. Do we have questions related to the approach or the project itself? We can do that afterwards as well, or today in the evening, maybe in a bar, so it's not so. Okay, thank you.
Thank you very much, guys. This is a great presentation, and I guess I do have a question. So in the recommender screen, you have the set points, the parameters. That's the main input for the operator at the line. How are they integrated with the design of that screen? Are you working with them in tandem?
Yeah, we had lead operators and process engineers that collaborated with us, but clearly, I mean, we tried to put a first product to the line quickly. And yes, for sure there will be changes to it. We know that there will be some additional product information references. There will also some more functions planned, how to write the changes directly to the machine, and that nobody needs to key it in. So there is some more steps to take, but we want to have a first product working in production.
Excellent, thank you. And we have a question in the back.
Yes, hi, thank you for the presentation. I had a follow-up question on the one that was just asked. So you have recommendations now. What needs to happen before these recommendations are taken by the system and just automatically steering your process?
Yeah, this is the last step maybe, yeah. But basically it's possible. You're right, yeah. But we said at the beginning we want to really check if everything is fine, and we want to have our self-control, let's say, because as you heard before, we have an accuracy about 93%, and we have our process engineers, and we have still our human knowledge in place and skills of our operators. And before we are not 100% sure that everything is working completely fine, yeah, then we can make that step as well. I'm with you. So there will be also a possibility to take exactly that set points as a proposal automatically for the next production run, for sure, kind of a machine parameter set. But this is the final stage when we are really sure that everything is running in the right direction. But good question.
Okay.